Everyone, I'm Nick, and in this episode of Clever Code, we're going to be talking about palindromes. So first of all, what is a palindrome? It's just a word that's spelled the same backwards as it is forwards. So a word like mom spelled M-O-M, right? If you reverse all the letters, it still spells M-O-M, mom. So how do we do this in C++? So we'll look at 4 different functions that implement it in 4 slightly different ways. So we'll open up palindrome.cbp. And the first one is a very C-style function, so we could port this very easily to a C program. So here we've got this is Palindrome Bad, and what we do is we get the length of the string, then we get a stopping position, so this will be the stopping point for our comparisons. The reason why we're doing this stopping point is because we don't actually need to do all pairwise comparisons, right, across the entire length of the string. So if you think of comparing the first letter to the last letter of the string, right, what we don't need to do is compare the last letter to the first letter, right? If we already compare the first to the last, we don't need to do the opposite, the last to the first, right? It's the exact same answer. So what we do is halfway, when we get halfway through the string, once we do, if our string is of length n, once we do n over 2 comparisons, right, we're done. We've compared all the letters we need to figure out our answer. So that's why we calculate the stopping position, performance optimization. So the next thing we do is we have a for loop. So we just compare all those pairs, gradually moving inwards, right? So on one side of the string, we're moving across, moving forward, and then we start from the end of the string and we're moving backwards until they meet at this ending point in the middle, which will be the stop position. So what's the downsides of this function? What's the upsides of this function? So the downsides, it's not very readable, right? So if we go through, we've got this length and stop calculation up here. It's not too bad, but okay, now we have to remember and know what stop means. Then we have a for loop in here, and then this is where it really starts to go down here. We have a conditional statement, which basically exits early if it's not a palindrome. But we have to remember, okay, what is this conditional statement actually doing? So we're indexing by I, and then we're also indexing by length minus I minus 1, right? So now it's not incredibly intuitive. If you just pulled that out of context and showed it to someone, you know, it might be difficult to figure out what's going on there, at least at first glance. And then you have to remember, okay, so why are we returning false here? Okay, the characters don't match in this pair, so it's not going to be a palindrome. And then otherwise return true. Okay, so we're returning true if it is a palindrome. That means we didn't exit up here. Okay, so big downsides, not terribly readable. But let's go to the pros, right? So in some of our other examples we've gone over, the first implementation is usually bad performance. In this case, this is pretty close to optimal performance, right? We're only doing as many comparisons as is absolutely necessary. We need to do length over 2 comparisons, right? And this for loop only does length over 2 comparisons at max, right? At the very maximum, it does length over 2 comparisons. So performance-wise, it's really good. So what we'd really like to do, and kind of the C++ way of having this zero overhead abstraction, we'd like to get this entire functionality, right, but in a lot more condensed fashion. It's much easier to understand, right? That's a little bit, we want something that's further away from the normal C style of coding. So let's look at 2 different implementations that do it a slightly different way. So what we can do, right, is we can change the problem. So in this case, what we do is we take a string, we make a copy of it now. So now we're making a copy into a string called R. We directly reverse R, and then we just have to do an equality comparison, right? So now we've reduced the entire problem to 3 lines of code. It's incredibly easy to understand because we see, okay, I'm making a copy of the string, I'm reversing it, and then I'm returning an equality comparison. So I'm comparing if the reverse string is the same thing as the normal string. Okay, so that's great in terms of readability. Now let's start talking about performance here. Well, we're no longer comparing characters, and we have the extra overhead of creating another string, and then whatever this reverse cost is going to be. And now reverse, we're actually having to do swaps of elements, not just comparisons, like our first example. So it's a completely different function that has its own costs associated with it, so it's going to be slower, right? It's going to be slower than just comparing, a single string, both because we're creating a copy, and then we're also calling another function. But it's very easy to understand. So what's another thing we can do? So similar to the previous solution, we can also just use reverse iterator, right, during construction. So instead of having to call reverse directly, we can just create a string, right, that's automatically reversed by passing to the constructor R begin and R end. So if you're familiar with iterators, right, begin points to the first element, end points to one past the last element. R begin and R end work in a very similar way, and they're really used for traversing something like a vector or an array in reverse. So R begin points to the last element, R end points to one before the first element. So when we pass these iterators, right, when we're constructing a new string like this, it basically just constructs a string in reverse, right? So it flips the order. So still we can do the same comparison, right? We can just do S is equal to R because R is going to be a reverse string. So there's some argument here that could be made, you know, is palindrome better 1? Is this one better than 2, right? Well, in 1 we're directly doing reverse, so you know, it's very easy to understand, but it's 3 lines of code. This one, if we understand what reverse iterators are doing, right, this one's not terribly difficult to understand either if you know what reverse iterators are. So but it really comes down to performance, right? And so both of these are going to be, you know, worse performance than this C style function that we talked about earlier, because they're making copies of strings and they're having to, you know, swap elements or construct something in reverse. So they have some overhead associated with them, and we'll go over that in a little bit. And then we have, is palindrome almost best? So we're getting really close to the solution we want. So we can still reduce it to a single line of code, right? And we just use the equal function from the standard template library. So we use the equal function, we pass in begin and end, so this is the range for our first string, and then we just pass in our begin, right? Which is the reverse iterator beginning, so the last element of the string. So you may be asking, well, why don't I also have to pass in for the second string, right? For the second string, why don't I have to pass in, say, our end of S, right? And the reason why is because the length is going to be determined by the first pair of iterators, right? So begin and end, this will set a length for the comparisons. So we only need to pass in the beginning of the second string to compare, right? In this case, we could just pass the reverse iterator. That way it traverses the string in reverse when it's doing these comparisons. So this is pretty close to optimal. It's a single line of code, and it'll probably be better performance than the other versions where we're actually making a copy, but it's not quite at optimal. And the reason why is because we forgot about an optimization that we did. Right? We forgot about this optimization where we had this early stoppage. So what we don't want to do, like we said earlier, we don't want to say compare the last element to the first and then have the other comparison of the first element to the last. Right? We don't want to have two comparisons that do the same thing. So we can fix that pretty easily by just changing the iterator slightly. So here we just have to do begin of S to begin of S plus s.length divided by 2. So we just have to say, what are we comparing? We're comparing from the beginning of the string to the beginning of the string plus length divided by 2, right? So it's the same calculation as above. We're just doing some arithmetic with iterators now. And then we just need to pass in again just a single iterator R begin for the second string. The reason why is because the length of the comparison will happen or will be calculated based upon the first string. So we don't need to pass in, you know, R end, you know, minus or R end plus s.length divided by 2. We don't need to pass in that as well. That length is calculated solely from this from the first string in this case. Okay, so now we've got the same or roughly the same performance as the first case, right? That's a very C-style function in a single line of code, right? It's slightly more complicated because we have to do this iterator arithmetic, but it's still pretty easy to understand. Okay, so we'll go ahead and check this for these 5 different solutions, and we'll check it for the word rotor. So rotor is it is a palindrome. It's spelled R-O-T-O-R. You reverse all the letters, it's still R-O-T-O-R. So let's go ahead and compile this. So we'll do G++ palindrome.cpp. Right, so I'll get this a.out and I'll run a.out. So they all find that it's a palindrome. And if I change it from rotor to say rotors, rotors is no longer a palindrome, right? Because if you reverse all the characters, now an S is first. So we'll recompile it and we'll run it again. You see they all find that it's not going to be a palindrome. So let's kind of recap everything. So we have this is palindrome bad function, and really the only reason why it's bad is because it's just a lot of code that does a very simple function. So we'd like to have the same performance but in a more compact form that's easier to understand and read. So we looked at 2 alternatives that construct strings in reverse using reverse iterators, or construct a string and use the reverse from algorithm to just reverse a string and do a comparison. Much easier to read, but they're going to take a performance hit. Then we have an almost perfect solution where we go ahead and we do the equality comparison, but we're forgetting our optimization where we stop early, so we're not doing twice as much work as we need to. And so we fix that in this last implementation. Again, with equal, we just have to do some arithmetic with the iterators. All right, so that's going to go ahead and do it for this video. And I wanted to acknowledge, so I made this video earlier and had to remake this video for a correction that pointed out this problem that I forgot to do the iterator arithmetic, and they were nice enough to also include a Google benchmark of these timings. So if you're interested in when I say something is close to optimal or very good, and the costs associated with this, so you can check to see that is Palindrome bad. So this is the one that's harder to read. It takes about 10.4 nanoseconds. I'm assuming that it's on the same word, say like rotor. Then they have is Palindrome better 1, so this is the one that uses reverse, right, from algorithm. It takes 31.9 nanoseconds, so about 3 times slower, right, but also it's 3 lines of code. And you see the one that's constructed with reverse iterators, right, it actually takes 44 nanoseconds, so about 4.5 times slower or so for 2 lines of code. Then we have is Palindrome best, right, so is Palindrome best is the one where we don't do the iterator arithmetic. So in our case, it would be almost best now. And you see it's about twice as slow as the C style function. And then once you fix the C style function, or once you fix rather the equal, and you only compare half the string now, so you do that iterator arithmetic, you're down to exactly the same performance or so as the original kind of C style function, the bad implementation. Right, so if anytime there's an issue with any of these examples, feel free to just let me know and take out an issue on, say GitHub. But that being said, all this code is, of course, available at github.com/coffeebeforearch. So if you go under repositories and you go under clever code, you see that I've got the find to odd, the max min, and the palindrome example all on here. So we looked at the palindrome example here. So feel free to check this out, play around with it, and let me know if you have any questions about what's going on in each of these or how to collect those performance numbers like we just showed. But that's going to do it for today. As always, I'm Nick, and I hope you have a nice day.